Yes, in the last class we have studied about potential energy of system of charges in the absence of electric field. In that we have taken single point charge is at the point A. Initially the point is having the potential is equal to 0. The reason is that there is no electric field as well as there is no one more charge carrier in order to carry the potential or potential energy. Last class we have discussed potential energy of system of charges in the absence of electric field. On the isolated point charge on a point A the potential on that point is equal to 0. The reason is that there is no presence of one more charge. A charge which exerts electric field as well as electrostatic force. But I field matte force and experience ಮಾಡಲಿಕ್ಕೆ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಇಲ್ಲ. ಹಾಗಾಗಿ ಏನಾಯಿತು ಕೇಳಿದರೆ the potential is equal to 0 for the single point charge. When the one more charge that is known as an Q2 that brought from the point infinity to the point B, now there is an work done. Because of the charge Q2, the charge Q1 is having the potential. When the charge Q2 that are brought from the point infinity to the point B, there is an work done. Thus there is a potential on Q1. That potential is expressed by in the last class. That potential is expressed by in terms of an energy. Potential is expressed by V is equal to or V1 is equal to 1 by 4 pi epsilon naught Q1 divided by R. This conclude that idra conclusion ಏನು ಕೇಳಿದರೆ single point charge ಅಲ್ಲಿ potential ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ 0. Single point charge ಅಲ್ಲಿ potential ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ 0 in the absence of electric field condition. But today's session I will start with the potential energy in an external electric field in the presence of electric field in that the first heading potential energy of the single charge. Suppose if you have taken one point, that point is expressed by A in an external electric field. Because of that electric field, the point itself is having the potential is called as an V1. ಮಕ್ಕಳೇ ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಏನನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ ಕೇಳಿದರೆ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನೋಂಥದ್ದನ್ನು ತಗೊಂಡ್ರೆ in the absence of electric field potential ಏನಾಗಿರ್ತದೆ ಕೇಳಿದರೆ 0. When the same charge that are brought over the point is known as an A, ಯಾವಾಗ ಚಾರ್ಜ್ ಅನ್ನು ತಂದು Q1 ಮೇಲೆ ಇಡ್ತೇನೆ ಅಥವಾ ಪಾಯಿಂಟ್ A ಮೇಲೆ ಇಡ್ತೇನೆ, that charge is known to be Q1. Again the potential is equal to 0 in the absence of electric field. But now there is a presence of electric field. Because of that presence there is a potential. Charge ಇಡುವ ಮೊದಲು ಏನಿದೆ ಕೇಳಿದರೆ the point A itself is having the potential and that potential is expressed by the term is known as V1. Is it clear? Puna repeat ಮಾಡ್ತೇನೆ. Where if it's taken one point, that point is taken as an A. The point itself is having the potential is called as an V1. It has a potential is because of an electric field. That potential is called as an V1. Before introducing the charge itself, the point A is having the potential. Now, the charge Q1 is brought from the point infinity to A. There is an work done. Therefore, the charge Q1 possesses the energy. That energy is given by U1 is equal to Q1 V1 is the expression for potential energy of a single point charge or the isolated point charge. Or in case of in the absence of electric field, if you are having the single point charge means the potential is equal to 0. In the absence of electric field ಅಲ್ಲಿ ಇದೇ potential ಏನಾಗಿತ್ತು ಕೇಳಿದರೆ 0 ಆಗಿತ್ತು. But ಈ ಕೇಸಲ್ಲಿ ಏನಾಗಿದೆ ಕೇಳಿದರೆ before introducing the charge over the point A, the point A itself is having the potential is called as an V1 is because of an electric field. That is the difference. Electric field iddu ಅಥವಾ ಇಲ್ಲದೆ ಇರೋದಕ್ಕೆ ಡಿಫರೆನ್ಸ್ ಏನು ಕೇಳಿದರೆ ಇದು. Therefore the point A is having the potential is called as an V1 when the charge Q1 is brought from the point infinity to A. Thus the charge Q1 possesses an energy is because of the initial potential. That potential is called as an V1. Therefore according to the general equation, potential energy on Q1 is given by U1 is equal to Q1 V1 is the expression. The next concept based on that, the next heading potential energy of a system of two charges. Here we are taken by the 2 points, point A and the point B in an external electric field. Here we are taken the 2 points, the point will be A as well as the B. Because of an external electric field, the point A is having the potential is called as V1. The point B is having the potential is called as V2. Before introducing the charge itself, charge ಅನ್ನು ಇಡುವ ಮೊದಲೇ ಅಥವಾ ಚಾರ್ಜ್ ಅನ್ನು ಪ್ಲೇಸ್ ಮಾಡುವ ಮೊದಲೇ ಏನಾಗಿದೆ ಕೇಳಿದರೆ ಪಾಯಿಂಟ್ ಎ ಮತ್ತು ಬಿ ಅಲ್ಲಿ ಏನಿದೆ ಕೇಳಿದರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ. ದಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ಆನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಆದರೆ ಪಾಯಿಂಟ್ ಎ ಮತ್ತು ಬಿ ಅಲ್ಲಿ ಯಾಕೆ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ ಕೇಳಿದರೆ is because of an external electric field. Now the charge Q1 is brought from the point infinity to A. Now the charge Q1 is brought from the point infinity to A. Now the charge Q1 possesses an energy. As I earlier discussed, U1 is equal to, that equation is known as U1 is equal to Q1 V1. Point A lane ಆಗ್ತದೆ ಕೇಳಿದರೆ energy develop ಆಗ್ತದೆ. The reason is that before introducing the charge itself, ಹೇಗೆ ನಾನು ಚಾರ್ಜ್ ಅನ್ನು ಇಡುವ ಮೊದಲೇ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನಿದೆ ಕೇಳಿದರೆ potentials ಇದೆ. That potential is expressed by V1. When the charge is brought from the point infinity to A, the charge Q1 possesses an energy. That energy is called as, at the point A, that energy is expressed by U1 is equal to Q1 V1. Similarly, the point B is having the potential is called as V2, is because of an external electric field. This V2 is because of an external electric field. ಇಲ್ಲಿ ಎಲ್ಲಿಂದ ಪೊಟೆನ್ಷಿಯಲ್ ಸಿಕ್ಕಿದ್ದು ಕೇಳಿದರೆ is because of an external electric field. ಪೊಟೆನ್ಷಿಯಲ್ನ ರೀಸನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರೋದ್ರಿಂದಾಗಿ. ಒಂದು ವೇಳೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲದೇ ಇದ್ರೆ ಏನಾಗ್ತಿತ್ತು ಕೇಳಿದರೆ the point B is also having the potential is equal to 0. But there is a presence of electric field, therefore the point B is having an external potential. That potential is called as V2. Therefore, when the charge Q2 is brought from the point infinity to B, ಈಗ ಏನು ಮಾಡ್ತಿದ್ದಾನೆ ಕೇಳಿದರೆ ಇನ್ಫಿನಿಟಿಯಿಂದ ಒಂದು ಚಾರ್ಜ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಎಲ್ಲಿ ತಂದಿಡ್ತಾ ಇದ್ದಾನೆ ಕೇಳಿದರೆ is at the point B. Now the charge Q2 is brought from the point infinity to the point B. Now the charge Q2 possesses an energy, since because of it is having the initial potential is called as V2. ಈಗ ಏನಾಯಿತು ಕೇಳಿದರೆ Q2 ಅನ್ನುವಂಥ ಚಾರ್ಜಿಗೆ ಎನರ್ಜಿ ಸಿಕ್ಕಿದೆ. ರೀಸನ್ ಏನು ಕೇಳಿದರೆ it is having the initial potential is called as V2. Therefore, according to the general equation, the potential energy on Q2 is given by U2 is equal to Q2 V2. Therefore, there is an initial potential V1 and V2 before introducing the charge, and these two potentials are placed at the two different points A and B, and that A and B are separated by the distance is known as an R. As now there is a presence of the two charge carriers. When the charge Q2 that is bringing from the point is known as an infinity to the point B, now there is an external work done. ಯಾವಾಗ ನಾನು ಚಾರ್ಜ್ Q2 ಅನ್ನು ಏನು ಮಾಡ್ತೇನೆ ಕೇಳಿದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ತಂದು ನಾನು ಪಾಯಿಂಟ್ ಬಿಗೆ ಪ್ಲೇಸ್ ಮಾಡ್ತೇನೆ. there is an external work done. That work done is stored as an energy. Therefore, the one more equation, because of the two charge carriers, ಇವೆರಡು equations ಯಾಕೆ ಬಂತು ಕೇಳಿದರೆ U1 is equal to Q1 V1 is because of the potential V1 is at the point A. U2 is equal to Q2 V2 is because of the initial potential is called as V2 is at the point B. Now we are placing the charges known as Q2. Therefore, the potential energy on Q2 will be U2 is equal to Q2 V2 because of the two charge carriers. ಇದರ ಮೀನಿಂಗ್ ಏನು ಕೇಳಿದರೆ ಯಾವಾಗ ನಾನು ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರನ್ನು ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಾಯಿಂಟ್ ಬಿಗೆ ತರ್ತೇನೆ, now there is a work done against electric field. Q1 electric field ನ ವಿರುದ್ಧ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ ಒಂದು ವರ್ಕ್ ಡನ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿದಾಗ ಆಯಿತು. ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂದಾಗಿ ಎಲ್ಲ is because of an external work done. That work done is stored as U3 is equal to, because of the two charge carriers, the two charge carriers are separated by a distance, that is separated by a free space. That is the reason why we are done by 1 by 4 pi epsilon naught, as I earlier discussed in the last session. U3 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R. Therefore, the total energy U is equal to U1 plus U2 plus U3. Therefore, U is equal to, what is the value of U1 is equal to Q1 V1 plus what is the value of U2 is equal to, the value of U2 is equal to Q2 V2 plus value of U3 is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught times of Q1 Q2 divided by R is the expression. Is it clear? In the last class we have studied about the potential energy of system of two charges in the absence of electric field. Last class ಅಲ್ಲಿ ನಾವು ಏನನ್ನು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಕೇಳಿದರೆ potential energy of system of two charges in the absence of electric field. Hope you remember. U is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R ಅಂತ ಬರೆದಿದ್ದೇವೆ. ಸೇಮ್ ಟರ್ಮ್ ಅನ್ನು ಬರೆದಿದ್ದೇನೆ, ಸೇಮ್ ಸೈಡಿಂಗ್. ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಟೂ ಚಾರ್ಜಸ್ ಇನ್ ಆನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಯಾವಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಇದೇ ಇಕ್ವೇಷನ್ ಅನ್ನುವಂಥದ್ದು ಹೇಗೆ ಮಾಡಿಫೈ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದರೆ ಅಟ್ ದ ಎಂಡ್ ಇಲ್ಲಿ ಬರೆದಿದೆ ನೋಡಿ ಹೀಗೆ. U is equal to Q1 V1 plus Q2 V2 plus 1 by 4 pi epsilon naught Q1 Q2 divided by R. That is the difference in the presence of electric field and in the absence of electric field. In the absence of electric field, the expression will be like this. Very important 3-mark question. Potential energy of system of two charges in the absence of electric field. Very important 3-mark question. ಇದನ್ನು ಸಹ ಕೇಳ್ಬೋದು ಅಥವಾ ಇದನ್ನು ಸಹ ಕೇಳ್ಬೋದು. ಬಟ್ ಈ ಕ್ವಶನ್ಸನ್ನು ಕೇಳುವಾಗ ಹೇಗೆ ಕೇಳ್ತಾನೆ ಕೇಳಿದರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅರದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಟೂ ಚಾರ್ಜಸ್ ಇನ್ ಆನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಹಾಗಾದರೆ ಎರಡು ಟರ್ಮ್ಗಳು ಎಕ್ಸ್ಟ್ರಾ ಇದೆ. ಬೇಸಿಕ್ ಇಕ್ವೇಷನ್ಗೆ ಕನ್ಸಿಡರ್ ಮಾಡುವಾಗ ದಟ್ ಇಕ್ವೇಷನ್ ಇಸ್ known as q1 v1 plus q2 v2 is because of an initial potential is called as v1 and v2 is because of an external electric field. Is it clear? Yes. Next concept, potential energy of a dipole in an external electric field for 3-mark question. In that, consider a dipole with the charge minus q and plus q separated by a small distance to e, which means consider a dipole with the charge minus q and plus q separated by a small distance to e in an external uniform electric field is called as an E vectors. ಇಲ್ಲಿ ಲೈನ್ಸ್ ಅಲ್ಲಿ ಏನು ಬರೆದಿದ್ದೇನೆ, that represents the uniform electric field. Uniform electric field in which we are placed by a dipole. In general, dipole is in a pair of equal and opposite charges separated by the unit distance is known as 2a, such that the dipole axis minus q to plus q ಇಂದ ಒಂದು ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ದೀರಿ. That line is called as a dipole axis, such that the dipole axis makes an angle is known as a theta is in the direction of electric field. Therefore, when the dipole is placed in an uniform electric field, is it clear? ನೋಡಿ, uniform in the consideration ಹೇಗಿದೆ ಕೇಳಿದ್ರೆ, initially we are taken by a dipole in an uniform electric field E vector. Uniform electric field E vector in which the dipole axis makes an angle is known as a theta. When a dipole is placed in an uniform electric field, the force experienced by the dipole, in general, the force experienced by the charge will be F is equal to QE for the isolated charge or the point charge. But the force experienced by the dipole will be equal in magnitude but is in opposite direction. Therefore, the net force on the dipole in an uniform electric field, very important, one more question, the net force on the dipole in an uniform electric field is equal to 0, since the force experienced by the dipole is equal and opposite. Therefore, here we have written some points. In that, the first one, the magnitude of the dipole moment P is equal to Q into 2A. That you already know this equation. The next one, the magnitude of the torque experienced by the dipole. The net force on the dipole will be 0. The net force on the dipole will be 0 since it experiences the forces are equal in magnitude but is in opposite direction. Therefore, the net force on the dipole in an uniform electric field will be 0, but it experiences a torque since the forces are equal in magnitude but is in opposite direction. That is the reason why it experiences a torque. Therefore, the magnitude of the torque experienced by the dipole is equal to torque is equal to P sin theta. Equation derivation first chapter ಅಲ್ಲಿ ಬಂದಿದೆ, electric charges and fields ಅಲ್ಲಿ. ಇಲ್ಲೇ ತನಕ ನೀವು ಪ್ರೂವ್ ಮಾಡಿದ್ದೀರಿ, ಅದರ ಕಂಟಿನ್ಯೂಷನ್ ಪಾರ್ಟ್ ನಾವು ಇಲ್ಲಿ ಬರಿತಾ ಇರುವಂಥದ್ದು. For that, the small amount of work done during this process, let dW be the small amount of work done, which indicating that in order to neutralizes the torque. ನೋಡಿ, ಯಾವಾಗ ನೀವು ಪ್ಲಸ್ ಕ್ಯೂ ಮತ್ತು ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜನ್ನು ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ಇಡ್ತೀರಿ, ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಸಮ್ ಓರಿಯಂಟೇಷನ್. ಈ ಮೈನಸ್ ಕ್ಯೂ ಮತ್ತು ಪ್ಲಸ್ ಕ್ಯೂ ಇಂದಾಗಿ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ, ಅಥವಾ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿಂದಾಗಿ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ, ಡೈಪೋಲ್ ತನ್ನ ಓರಿಯಂಟೇಷನನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ. ಈ ಓರಿಯಂಟೇಷನನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿರುವಂಥದ್ದು ಅಥವಾ ರೊಟೇಟಿಂಗ್ ಆಗಿರುವಂಥ ಡೈಪೋಲನ್ನು ನನಗೆ ಏನು ಮಾಡಲಿಕ್ಕೆ ಹೊರಟಿದ್ದಾನೆ ಕೇಳಿದರೆ, ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಹೊರಟಿದ್ದಾನೆ. ಇನ್ ಆರ್ಡರ್ ಟು ಬ್ರಿಂಗ್ ದಮ್ ಬ್ಯಾಕ್, ಇದನ್ನು ನಾವು ಪುನಃ ಈಚೆಗೆ ತರಬೇಕು. ಹೀಗೆ ಲೆಟ್ ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ಇನ್ ಆರ್ಡರ್ ಟು ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್, ದಟ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದಿ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ದಟ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಟಾರ್ಕ್. ಎಷ್ಟು ಟಾರ್ಕನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ರೊಟೇಷನಲ್ ಅಥವಾ ರೊಟೇಟಿಂಗ್ ಇಫೆಕ್ಟನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ದೀರಿ, ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಅಮೌಂಟನ್ನು ನಾನು ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ನನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಬೇಕು. Therefore, let dW be the small amount of work done during this process, which means that small amount of work done is needed in order to bring them back, which means in order to bring the dipole in a particular orientation. ಈ ಓರಿಯಂಟೇಷನ್ ಇರುವಂಥ ಡೈಪೋಲನ್ನು ಪುನಃ ಡೈಪೋಲ್ ಆಕ್ಸಿಸನ್ನು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಫೀಲ್ಡ್ಗೆ ತರಬೇಕಾದ್ರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಅನ್ನುವಂಥದ್ದನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಬೇಕು. ದಟ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ದ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಡ್ಯೂರಿಂಗ್ ದಿಸ್ ಪ್ರೊಸೆಸ್ ಈಸ್ ಗಿವನ್ ಆಸ್ dW is equal to torque into d theta. Force in terms of a torque. Displacement is in the nature of an angular displacement. That is the reason why we are expressed by d theta. Therefore, change in work done dW is equal to torque into d theta. That is equal to, what is the value of torque is equal to, that I already written here. Torque is equal to P sin theta. D theta is as usual. Now, therefore, the total work done is from rotating the dipole from theta 1 to theta 2, which means that when the dipole that are bring back to the original position. ಯಾವಾಗ ನೀವು ಓರಿಯೆಂಟೇಷನ್ ಇರುವಂಥ ಡೈಪೋಲನ್ನು ನೀವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ತಿರುವಂಥದ್ದು ಡೈಪೋಲನ್ನು ಸಪೋಸ್ ಈಗ ಇಟ್ಟಿದ್ದೀರಿ ಅಂತ, ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ -q ಮತ್ತು +q ಅಲ್ಲಿ ಹೀಗೆ ಇಟ್ಟಿದ್ದೀರಿ. ಸದ್ಯ ದ ಡೈಪೋಲ್ ಆಕ್ಸಿಸ್ ಹೀಗೆ ಇರ್ತದೆ. ಬಟ್ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ಏನಾಯಿತು ಕೇಳಿದರೆ ಡೈಪೋಲ್ ಮೇಕ್ಸ್ ಅನ್ ಓರಿಯೆಂಟೇಷನ್. ಸೇಮ್ ಡೈಪೋಲ್ ಅನ್ನುವಂಥದ್ದು ಏನಾಯಿತು ಕೇಳಿದರೆ ಈ ರೀತಿಯಾದಂಥ ಆ್ಯಂಗಲನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದೆ. ನಾವು ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ರಿಕ್ವೈರ್. ಆ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಹೇಗೆ ಇರಬೇಕು ಕೇಳಿದರೆ ದಟ್ ಇಸ್ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಟಾರ್ಕ್. Therefore, that work done is considered as a small amount of work done is equal to the torque in order to neutralize the dipole. ಪುನಃ ಈ ಡೈಪೋಲನ್ನು ಪುನಃ ನೀವೇನು ಮಾಡಬೇಕು ಕೇಳಿದರೆ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಬೇಕು. Therefore, we are using an external work done. Based on that, we are written the equation. Therefore, in this process, the total work done is rotating a dipole from θ1 to θ2 is taken as W is equal to integration of dW is equal to the limit is from θ1 to θ2. That is a change in angle. ಈ θ1 to θ2 ಏನನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ ಕೇಳಿದರೆ ಚೇಂಜ್ ಇನ್ ಆ್ಯಂಗಲನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ. Therefore, work done is from θ1 to θ2 is equal to θ1 to θ2 times of P sin θ d θ, that is equal to P is a magnitude of the dipole moment, that is constant. Uniform electric field, that is also constant. We have to integrate the function is known as sin theta d theta. You have to integrate the function is called as an sin theta d theta. Therefore, that is equal to Pe θ1 to θ2 sin theta d theta is the variable. Since there is a change in angle with respect to the angular displacement, therefore W is equal to Pe is as usual. The integration of sin theta d theta will be minus cos theta. Now the limit will be θ1 to θ2, upper limit will be θ2, lower limit will be θ1. By substituting the limits, W is equal to minus of Pe. In the next step, W is equal to minus of Pe, minus equation ಅನ್ನು ಹೊರಗಡೆ ಇಟ್ಟು ಬರೆದಿದ್ದೇನೆ. Therefore, W is equal to minus of Pe by applying the limit in the place of θ2, therefore cos θ2 minus of cos θ1. This work done is stored as in a potential energy of the dipole. ಆದರೆ ಈ work done ಹೇಗೆ ಸ್ಟೋರ್ ಆಯಿತು ಕೇಳಿದರೆ potential energy of the dipole. Therefore, work is done only in rotating the dipole. ನೋಡಿ ವರ್ಕ್ ಡನ್ ಏನಾಗಿದೆ ಕೇಳಿದರೆ ಇನ್ ಆರ್ಡರ್ ಟು ರೊಟೇಟಿಂಗ್ ದ ಡೈಪೋಲನ್ನು ಎಕ್ಸ್ಟರ್ನಲ್ ಟಾರ್ಕ್ನ ವಿರುದ್ಧ ಟಾರ್ಕ್ನ ವಿರುದ್ಧ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ನನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಆ ವರ್ಕ್ ಡನ್ ಹೇಗಿದೆ ಕೇಳಿದರೆ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ರೊಟೇಟಿಂಗ್ ಹೇಗಿದೆ ಕೇಳಿದರೆ ರೊಟೇಟಿಂಗಲ್ಲಿದೆ. Therefore, ವರ್ಕ್ ಈಸ್ ಡನ್ ಓನ್ಲಿ ಇನ್ ರೊಟೇಟಿಂಗ್ ದ ಡೈಪೋಲ್ ಫ್ರಮ್ ದ ಪೊಸಿಷನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಫೀಲ್ಡ್. From the position is perpendicular to the field to the any other position, perpendicular to the field to the any other position. Therefore, θ1 is taken as π/2. Initially ನಮ್ಮ assumption ಏನು ಕೇಳಿದರೆ ಈ ಡೈಪೋಲ್ನ ಆಕ್ಸಿಸ್ ಹೇಗಿದೆ ಕೇಳಿದರೆ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದೆ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರಿಂದ ನೀವು ಯಾವುದೇ ಆಕ್ಸಿಸ್ಗೆ ಅಥವಾ ಯಾವುದೇ ಆ್ಯಂಗಲಲ್ಲಿ ತಂದಿಟ್ಟಿರ್ಬೋದು. ದಟ್ ಇಸ್ ಅನ್ ಅನ್ನೋನ್ ಆ್ಯಂಗಲ್. ಹಾಗಾಗಿ θ2 is equal to θ ಅಂತ ಬರೆದಿದ್ದೇನೆ. Therefore, work is done. Very important consideration. Work is done only in rotating the dipole from a position perpendicular to the field to any other position. θ1 will be known, that is π/2 90 degree, which means perpendicular. θ2 will be any angle, ಯಾವುದೇ angle ಇರಬಹುದು. Therefore, that is expressed by θ itself. Therefore, by substituting the values of θ1 and θ2 in this equation, θ1 is equal to π/2, substituted here. θ2 is equal to θ, therefore W is equal to minus Pe is as usual. In the place of cos θ2 will be written as θ itself. Equation minus is as usual. Cos θ1 is expressed by π/2, therefore cos π/2. Cos 90 will be 0. Therefore, W is equal to minus Pe cos θ is the equation. This work done is stored as an energy. Therefore, according to the definition, work done is replaced by U. Therefore, U is equal to minus Pe cos θ in terms of a vector form. Work done is in a scalar. Therefore, U is equal to minus is as usual. Cos θ is replaced by the product is called as in a dot. Therefore, U is equal to minus P vector dot E vector is the expression. For a 3-mark question for the board exam, arrive an expression for potential energy of a dipole in an external electric field. It is the continuation of torque experienced by the dipole in an uniform electric field in the first chapter. First chapter ಅಲ್ಲಿ ನೀವು torque experienced by the dipole ಅನ್ನು ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಿ. 3-mark ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಅದರ ಕಂಟಿನ್ಯೂಷನ್ ಪಾರ್ಟ್ ಇಲ್ಲಿ ಕಂಟಿನ್ಯೂಷನ್ ಏನಿದೆ ಕೇಳಿದರೆ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಅಗೇನ್ಸ್ಟ್ ದ ಟಾರ್ಕನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಏನು ಓರಿಯೆಂಟೇಷನನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ದೀರಿ. ಇಲ್ಲಿ ನೀವೇನು ಮಾಡ್ತೀರಿ ಕೇಳಿದರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ನನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ. ದಟ್ ವರ್ಕ್ ಡನ್ ಈಸ್ ಅಗೇನ್ಸ್ಟ್ ದಿ ಟಾರ್ಕ್ ಇನ್ ಆರ್ಡರ್ ಟು ನ್ಯೂಟ್ರಲೈಸಸ್. ರೀಸನ್ ಏನು ಕೇಳಿದರೆ ಇದೇ ಡೈಪೋಲನ್ನು ಓರಿಯೆಂಟೇಷನಲ್ಲಿರುವಂಥ ಡೈಪೋಲನ್ನು ನೀವು ಏನು ಮಾಡಬೇಕು ಕೇಳಿದರೆ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಬೇಕು. ದರ್ಫೋರ್ ದರ್ ಇಸ್ ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ರಿಕ್ವೈರ್. ಈ ರೀತಿ ಓರಿಯೆಂಟೇಷನ್ ಇರುವಂಥ ಡೈಪೋಲನ್ನು ನೀವು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಡನ್ ಅನ್ನುವಂಥದ್ದು ಬೇಕು. ದಟ್ ಇಸ್ ದ ರೀಸನ್ ವೈ ವಿ ಆರ್ ಟೇಕನ್ ದಿಸ್ ಪ್ರೊಸೆಸ್. Yes.